Watch out for the riders. Whoa. Keep an eye out for the riders.
Hi, my name is Anil Nair, and I'm an aerospace engineering student here at UCLA. And I'm going to help you by going over some math concepts and examples. Good luck. We're going to go over chain rule and implicit differentiation. So to start things off, I'm going to show you what kind of questions we can solve with this. So if we have p of x equals 2x to the fifth plus 1 to the 100th power, we want to find p prime of x. How do we go about doing this without multiplying this whole thing out? So that's one question. And then another question would be, if we have this equation here, which has a graph associated with it, how can we find dy dx? This is an explicit or sorry, not explicit, it's implicit. This is implicit because we haven't solved for y. We just have x's and y's mixed together. So we're gonna figure out how to solve these problems. So the chain rule is used for when we have functions within functions. So let's say we have functions f of x and u of x, and they're both differentiable. Let's call it diff for short. And let's say we define a function h of x. The 3 bars mean we're defining it to be f of u of x. Which can also be written as f of u of x. So we want to find the derivative of h prime. So the chain rule tells us that the derivative of h prime is going to be f prime of g of x, or sorry, not g. You can use g instead of u, that's what the book uses. But u will tie into other things. So that's pretty much what the chain rule says. The derivative of a function within a function is equal to the, I'm sorry, I put g again, is equal to the derivative of the outer function with the inner function still present inside, times the derivative of the inner function. So, and I'll show you kind of why this makes sense. This is kind of like dh du, because we have u, we're differentiating with respect to u. And u prime is kind of like du dx. And if we kind of cancel these u's, which we can't really do, but you can see we get dh dx, which is what we're looking for. So to answer our original question, we have p of x equals 2x to the fifth plus 100, or sorry, not plus 100, plus 1 to the 100th power. If we just write this in terms of our chain rule, so f of x is the outer function, which is something to the 100th power, we'll call it x to the 100th power, and our inner function is u of x, which is 2x to the fifth plus 1. We take the derivatives of both of these, we get f prime of x equals 100 x to the 99, and u prime of x equals n x to the fourth. So if we want to find p prime of x, we're just going to get f prime of u of x times u prime of x. Well, f prime of u would be 100 u to the 99th power, u being 2x to the fifth plus 1, 99th power, times u prime, which is 10 x to the fourth, which gives us 1,000 times x to the fourth times 2x to the fifth plus 1 to the 99th power, which is a lot easier than multiplying 2x to the fifth plus 1 to the 100th power than taking the derivative of that. So now back to our second original question. We have x squared plus y squared equals 1, and we want to find dy dx. Well, we're trying to put everything, we want to put things like in terms of y as a function of x, right? This is the form we want, y equals y of x. So we can make the assumption that y is a function of x, and then rewrite our equation as x squared plus y of x squared equals 1, with y just being some function of x. Now if we just take the derivative of both sides with respect to x, we can split this up. So we know the derivative of a constant is 0, so we get 0 on that side. The derivative of x squared is 2x. So for this, we just use the chain rule. We have function on the outside, something being squared. So we could write it like this if we wanted to. F of x equals x squared, something's being squared. U of x is just y of x. So f prime of x is 2x. U prime of x is just y prime of x, which is just dy dx. So this is going to be f prime of u times u prime of x. This is going to give us 2 times u, which is y. So 2y, we can leave out the of x part. Let's just put it in for now. Times u prime, which is just dy dx. So now we just solve for dy dx. We subtract the 2x over, then we divide both sides by 2y. 2's cancel, and we get dy dx equals negative x over y. So the basic method of implicit differentiation is just write y as y of x, then differentiate both sides. Use the chain rule on your y wherever you see it, and then solve for dy dx. And you'll see more of this in the example.